Okay, in my last video I showed you how we could solve a system of two equations and two variables by graphing, and you would interpret the answer to be the point of intersection. It's like each equation represents a straight line, and if you drew two straight lines, they could intersect somewhere, and that spot is the solution. And if that wasn't enough for you, I took that point, those numbers, I put it into the original problem, and it worked all the way through. Okay? Now, for now, I just want you to keep this in mind. I'll show you some others that don't seem like they have anything to do with that one, but I'll come back and I'll tell you why the graphing or the geometric interpretation does have something to do with the story. Okay? So here we have a problem that you might see in the book or on the My Math Lab assignment. And we're supposed to solve it, and we have to decide on a method. Okay? And why is it important to decide on a method? Well, because we've got the substitution method, where I would normally recommend that if one of the equations is solved specifically for y or x, like that one says y equals, it makes it easy to substitute that directly into the other one. If that's not true, then we might use the addition method, okay? But I guess you can solve any problem any way that you can get to work. Those are just basic guidelines, okay? Now, so let's see, with this one, how would you solve it? Well, I actually, as I look at this, I see that the substitution method could work. Here's why. The top equation says 4x is the same thing as y minus 7. But you see that same 4x right there. What's 4x again? According to that, it's y minus 7. So you could take that down to just an equation with y in it. Remember, when we do this, we start with one equation, two equations and two variables, and we have to get to the point where there's one equation and one variable. That's what takes us to an answer. So I actually think I'll do like this. I'll call this equation A and this B. And I think I can sub A just the way it is into B. Okay, so here's how. Equation B says 4x minus y, but equation A says 4x is y minus 7. So it's like y minus 7 minus y equals 3. Okay? Now, if that's a little bit hard to see, just notice that, that part right there, according to equation A, is the same thing as 4x. All right? Okay. Now, what do we have? We started with two equations and two variables, and now we have one equation and one variable. That should take us to the answer. Okay, say something definitive about what the answer is if we take this a little further. So y minus y, to combine those, since they're like terms, those cancel, and it says negative 7 is equal to 3. Okay, now that doesn't mean the answer is negative 7. It doesn't mean the answer is 3. It doesn't mean the answer is negative 7 and 3. Okay, think about what that says. That says negative 7 equals 3. The y and the x have totally dropped out of it. Is that something you agree with or not? Is negative 7 actually the same number as 3? No, that's definitely not true. Crazy. It's a false statement, and here's how we interpret that. If we have some initial problem, and we do all of our math correctly, all the variables drop out, and we get a false statement such as negative 7 equals 3, then that just means there's no solution. Okay, and that's all we say about it. Okay, now why would I have started the video by saying that you could interpret the solution of any of these problems as the point of intersection of their graphs? Well, is it possible that you could have two lines that never actually cross? Parallel lines never cross, okay? So we could say, something like this is true, that if I graphed each of them, if I took the trouble to do that, they would be parallel lines, and parallel lines never intersect. And since they never intersect, that problem doesn't have an answer, okay? So we'll give this as our final answer, but we'll have to be aware that what's going on behind the scenes is the fact that that equation and that equation are each lines that are parallel on the graph and therefore never intersect each other, okay? All right, so there's that, all taken back down to geometry. We can interpret the answer in terms of geometry if we want, if that helps us think about it. Let's try to do this next one, okay? I have some comparing and contrasting I want to do between these two problems. So, again, if I look at it, I guess it looks like any of the others. I just have to decide how I'm going to do it. I could use the elimination method where I multiply one or both equations by numbers that allow a variable to cancel, or I can use the substitution method, substituting one equation directly into the other. And I think because that first equation makes an obvious statement about the x, it says x is 3y plus 1, it'd be easy to substitute that one into the next one, okay? All right, so here goes. Let's call this A and B. And if I do that, it'll make it a little bit easier to write down what I plan to do. So here I think I can substitute equation A into B, where A says x is the same thing as 3y plus 1. So if we make that substitution in that way, it says negative 3 times 3y plus 1, which amounts to saying negative 3 times x plus 9y equals to negative 3. All right, now we have this common theme with every problem. We start with two equations and two variables, and we reduce it to having one equation and one variable, and that's where we really get the answer. All right, so all right, here goes. Negative 9y to multiply through here, minus 3 plus 9y is negative 3. I notice that to take it further, the 9y's cancel, and I get negative 3 on the left, negative 3 on the right. This is kind of like that one in that all the variables dropped out. But is that true or false? Is negative 3 equal to negative 3? That's true. That doesn't mean the answer is negative 3. That's a true statement. So how do you think you interpret a true statement? Well, think about it like this. There's three situations that we can have. Every single problem like this is two lines. What are the possibilities? Two lines could intersect at one spot and have one answer. Two lines could never intersect, being parallel lines, and that means that there's no solution. Or it could be, here's the third option, that the two lines, even though they look different, are actually the same. Like one line on top of the other. Okay? And where do they intersect? If those lines are the same, and you drew one of them, and then you drew the other one, where would they intersect? They would intersect everywhere. Every single point all the way through would be an answer. Every single point would be an intersection. So what we say about that is that there's infinite solutions. Okay? Infinite solutions because, in fact, those two lines are actually the same as each other and therefore intersect at an unlimited number of spots. Okay? So we say infinite solutions in that case. Okay, so for the next thing in the video to take us through the lesson is this. As I started my videos in this series with this slide right here, I was working up to us doing 3 equations and 3 variables. And what would that look like is probably just what you think it would look like something like this. Okay, there are in fact 3 equations, and there are 3 unknowns, x and y and z. So just to anticipate something, if I'm going to give my answer like we have done in the other problems, it's going to look something like this, where in my answer, or through getting the answer, I tell you what every unknown should be in alphabetical order. X and y and z. There's this right combination, this perfect combination of x, y, and z that makes all 3 of these equations true. Okay, that's what a solution would be. And we call that an ordered triple. And we still write in alphabetical order, x before y before z. Okay, now the only way that I'll recommend that you solve these is through the addition method. Okay? All right. And what that will mean is taking the equations, multiplying them by numbers of your choice that would allow us to eliminate a variable. Okay? And I could explain the whole thing, but I really think that it's easier to just show you. All right, so I'm not going to explain the whole procedure. I'll just show you what it looks like, and then you can practice it in the way that you see it. All right? So if I'm going to do this, I like to label everything, and I like to keep track of it. Okay? All right, so that'll be equation A and B and C. And if I'm going to solve this every single time I do anything, no matter which problem I'm doing in this lesson, I have to reduce it all the way to the point where there's just one equation and one variable. Okay? So the way that we start this off is we look and we see, well, what would be easy to do? Would it be easy to knock out the x or the y or the z? Okay? All right, so I'm going to write my steps like this. Here's how I'll proceed. I will eliminate z because I notice how they're like already, I got a negative z and a negative z. They could almost cancel if that was just a plus. And it's not that hard to modify it that way. So I'm going to eliminate the z. And when we pick whatever variable we're going to first eliminate in a 3x3 system, 3 equations, 3 variables, we have to do it twice. Okay? All right, I'll show you why as I do it. Because like I said, it's easier for me to just show you than tell you. So here goes. The first way I'll eliminate z is I'll do like a -1 times equation b, and then I'll add equation c to it. All right? Look at what that would be. What's -1 times equation b? A negative x minus 2y plus z equals 0. So you take equation b, multiply everything on both sides by the number -1. Okay, so that's what we do. And that's what it would look like. Double check your math, because with all this... Okay, so -1 times b plus c, there's -1 times b. And then, so I have to double check everything, all right. And then we just add c the way that it is. We don't have to change it or modify it in any way if we're going to get the z to cancel. So look at c right there. We get 10x minus y minus z is equal to 30. So that's what -1 times b plus c looks like. Okay. Is it going to work the way that we want it to? Will the z's cancel the way that we modify it? Yes, that was our plan. So it's working out like we want, and that's a good thing, of course. And what am I going to get? -x plus 10x, that'll be 9x. And then -2y minus y, will be minus 3y. The z's cancel, but that was the plan. And then for numbers, I get 30. Okay? All right. So there, I get that. 9x minus 3y is 30. Now, I said I would just try to show you how to do this and not explain the whole philosophical basis for it, but see how it works here? If you have 3 equations and 3 variables, you can solve it. If you have 2 equations and 2 variables, you can solve it. 1 and 1, you can solve it. But as we do this, when we have this problem, we turn it back into that one to finally get an answer. And then when we have this one, we turn it into this, and then turn it into that. So it's like we're always going back. Now I started by 3 by 3. Now I've got 2 variables. Can you solve an equation if it has 2 variables in it? No. You need 2 equations and 2 variables. So that's why you have to eliminate the z twice. All right? So there's once. Now you have to eliminate the z again in a way that's different from the way you just did. So look at those, and what's another way you could eliminate the z? Could you do between b and a somehow, or c and a? You already did b and c. So as I look at it, I think that if I made a 6 right there, if I multiplied through by 6 in either of these, it would cancel with that. So you could modify equation b or c by multiplying by 6. Now, which one would be easier to multiply by 6? If you multiply all the way through here by 6, 6 times 0 is 0. If you multiply all the way through there, 6 times 30 is 180. Let's use b. Let's do 6 times b plus a. That'll be our second way to eliminate the z. Okay, so to do the math, 6 times equation b. Take 6 all the way through by equation b. We'll get 6x plus 12y minus 6z is, what's 6 times 0? 0. And then you add equation a. You get 2x minus 10y plus 6z is 22. Is that going to work out the way that we wanted to? The plan was to eliminate the z twice, and yes, the z will be eliminated again. Okay, so adding term for term, the x's give me 8x. The y's give me 2y. The z's cancel, and that was my plan, and then I get 22. Okay, so if you do it this way, if you choose a variable out of there to eliminate twice, then you get a 2 by 2 system. You have 2 equations in the same 2 variables, and we've already learned how to do that. So let's say like this. Now we see it as that we solve those together. All right? So it's like we get 9x minus 3y is 30. Solve that together with this equation, which has the same 2 variables in it. 8x plus 2y is 22. Now I hope you look at that and you think, well, I could cancel the x's maybe, or the y's, and I'll get an answer at that point. I hope that you look at this. You see how this first step feeds into the next one by just turning it back into a problem like that one that we've already seen. You got x and y, you eliminate either the x or the y, and you get an answer, okay? All right, so let's do like this. We're back like to 2 equations and 2 variables. We had 3 and 3. Through eliminating z, now we have 2 and 2. And we got a label, so I got a, b, c. Let's call this one d, and let's call this one e, okay? Now, which variable would you eliminate out of that? X or y? I think it'd probably be easier to eliminate the y. Okay? And I got 3 and 2. What could you turn those into some common number through multiplication? We can make them both a 6. And that's already a minus, and that's a plus. So they'll cancel. Let's do 2 times d plus 3 times e. Okay, and that will accomplish what? That will eliminate the y. Okay, and once the y is gone, we're down to the x, and then we'll have an answer. Okay, all right, now what does it look like to do 2 times d plus 3 times e? Well, 2 times d, that'll be 18x, 2 times 9, minus 6y, 2 times 3, and I'll get 60. 3 times e, so 24x, 6y, and 66. Okay. And my plan was to eliminate y, and it looks like that will work out. I got a negative 6 and a 6. All right. And that's always, I mean, if you do your math right, a way that you could check and make sure that working according to plan. Otherwise, if I had 18 and 24, I'll get 42x. And over here, I'll get 126 after the y's cancel. Okay. Anyway, so that's what we do, right? Now, so as we got one equation in one variable, we could just divide by 42, and it goes 3 times into 126. So let's just say 3. 126 over 42 is 3. We get our first answer. The first of 3, we're a third of the way there. Let's do this. Let's say 3 is not the whole answer, but 3 is 1 out of 3 parts. I don't know y or z yet. I just found the x. Now, how do you think you find the y or the z? Through back substitution. We'll take this answer. We'll just look upwards a little bit and realize we can find the y. And then we have x and y. And we'll look up a little bit more, and then we can find the z. So through back substitution, let's go like this. We'll say, okay, I know that x is 3. That's a 3. That's a 3. Just decide which of these would be easier to work with to get y. I'll go ahead and I'll put it in e. It doesn't matter if you use d though, but I'll put it in e. And what's it going to say? 8 times 3, because x is 3, plus 2y is 22. So I'll get 24 plus 2y is 22. So I'll get 2y is negative 2. And y is negative 1. Okay? So that's the second of 3 answers. Negative 1 for y. What about z? Now, if I show you, like say I show you this much of my work, z doesn't even appear on the paper. I've got to look like further back up, like all the way to the beginning. So we know x and y. So up there somewhere, given that you know x and y, where do you think the best place to find z is? You can use equation A, B, or C, but which one's simplest? B, okay? So I'm going to do this. I'll say, we'll take this further, and we'll put it back in the very beginning up there in B. The fact that we know x is 3 and y is negative 1. What's that equation B going to look like? All right. So it'll say 3 plus 2 times negative 1 minus z equals 0. And z is the only thing left to solve for at that point. We'll get 3 minus 2 minus z is 0. We'll get 1 minus z is 0. We'll get negative z is negative 1, or z is 1. Okay. Then we got the last missing thing in the problem. Z is equal to 1. Go all the way back up here. It's 1. There's our answer. Be easy to check it. Put 3 for x all the way through. Negative 1 for y. 1 for z. All the way through. It's going to work in each one of them. Okay. So that's how we solve a 3x3 system. To do with paper and pencil, it's a lot of work. But the steps are predictable. Look at it. Choose a variable to eliminate twice so that you get 2 equations in the same 2 variables. then solve those against each other by eliminating a variable. Get an initial answer, back substitute somewhere, get another one, back substitute further, get the last one. That's how they're going to be. Let's look at one more example like this. And here it is. Okay, 3 equations, 3 variables, like the last one. You know, I definitely see 3 equations, and all throughout it there's x and y and z. Grand total 3 equations, 3 variables. Now this one does look different. There's a gap right there. There's no z in the first equation, but I think that that could make it actually a little bit easier for us. Okay. Remember, I have to, in order to solve this, decide if I'll eliminate x or y or z in a way that I get from that 2 equations in the same 2 variables that I solve against each other. Now z's already missing from this one. Say you eliminated the z between these two. What would be left? X and y. And you could use whatever you get out of that to work against this one. So, you know, I wish when we do math, I could tell you that we always do everything exactly the same way, but that's not true. I mean, in this other problem, I said, pick a variable to eliminate and do it twice. Okay, well, because the z is already missing there, we don't have to do that twice. But I want you to see that we still get to the same kind of place, even if we do it a little bit different. Okay? So here's my step. Here's what I want to do. I will eliminate the z only one time this time between equations b and c. And I don't even have to modify them. The z will already cancel. All I have to do is take equation b and add c to it. Okay? So if you want to write it down again, x plus y minus z is 12. 5x plus 3y plus z is 0. And yeah, the z's will cancel right out of that right away. You'll get 6x plus 4y. Z's gone. 12. Okay? Now look, this equation has x and y in it, and so does that one. Use those against each other to knock another variable out. Let's do this. Let's call this equation D, and I'll put my second step as now solve D and A. Why? Well, because they have the same 2 variables between the 2 equations. So look at them together. Here's D. 6x plus 4y is 12. Okay. And then A. All right. 2x plus y is 4. Yes, they both have x and y in them. Okay, figure out some way to cancel either the x or the y, and you've got your answer. All right, so here's D, here's A. How about this? I mean, I guess I could multiply this equation by 3, and that would become a 6, and I could knock that out. Or I can multiply this equation by 4, and that would become 4, and it would knock that out. I think it'd be easiest to eliminate the y. Okay? And the way I'll do it is I'll say negative 4 times equation A plus equation D. How's that going to look? All right, negative 4 times equation A, I'll get negative 8x minus 4y is negative 16. Okay, negative 4 times A plus D, 6x plus 4y is 12. Add them together. Negative 2x right there. Those cancel. That was my plan. And then I get negative 4. Okay. Yeah, so I'm to the point where I can get an answer, right? One equation, one variable. Negative 2 times what's negative 4? X would be 2. All right. So we'll substitute back into the others. You saw how I did that in the other video, so I'll just give you, or in the previous problem. So here's what our answer will be. Okay? I find x, y, and z. X is 2, and you'll find that y is 0, and z is negative 10. Okay? That's the easy part, I think. Once you get that first answer, you substitute back here. All right, from x you can find y, and when you know x and y, you substitute back up there, and then you can find z. All right, so here's a problem that's similar but different. That's why I wanted to show you both of those last two problems in consecutive order.